The classes of amplifier will explain how that amplifier circuit operates. Now, when we look at the output characteristic of an amplifier, which includes a load line, we will find the following. If we have the Q point right in the middle, it is a class A amplifier, which means from the input to the output we will have a large or a very small area of amplification. Okay, so the amplification is low gain, okay, but it has the ability to amplify 360 degrees of my input wave. There's no distortion, and as a result it is used for low gain amplifiers or for pre-amplifiers. Now if we look at the class B amplifier, remember our amplifier will have that area there, which is the saturation, and that area there, which is the cutoff. Okay. The moment the signal enters into the saturation or the cutoff, we're going to have distortion. In other words, a portion of the waveform is going to be cut off. Now with the class B amplifier, we will have our input on the, or our Q point on that point over there, or conversely that point over there. The result is that it can handle a much larger input signal, and as a result the output signal will be much greater. The problem, however, is the negative half cycle, or one of the half cycles of these waveforms is going to be completely lost. So the class B has a high gain, okay, it can amplify 180 degrees of my input signal, and as a result it has the ability to be used in either amplifying the positive or the negative side of a signal. My class C amplifier, has its Q point way outside of my graph, way outside of my axis. As a result, it'll go and amplify just the tip of my input signal. Okay, as a result, my class C is used primarily for switching. The class C is used primarily for switching. It amplifies less than 180 degrees. Okay, but it has a very high gain. Disadvantage again, there's distortion, same as with the class B. The distortion comes because the transistor is actually switching out of the active into the cutoff or the saturation region. The final is called my class AB amplifier. This is a combination of the class A and B, and as a result we will find that the Q point lays between the class A and the class B. The result for this is that the gain still is high. It amplifies between 180 degrees and 360 degrees of my input signal. It only clips off a portion of the waveform, this little area there, okay, and it's usually used in push-pull pairs or crossover amplifiers, which we will look at later on. Now the concept of feedback. During amplifiers we touched on today. We will have an input signal that input will connect to my amplifier that has a specific gain. That then serves to my output, and we will have a portion of the input signal fed back and added. We will have a portion of the output signal fed back and added to the input signal to serve as my value, or that is actually being amplified. Now, Vs, or the signal that is actually being amplified, is equal to the input voltage plus the product of the output and the feedback percentage that we got with the op-amp type circuits. Now, when this ratio is positive, it is called positive feedback. Now the problem with positive feedback is our amplifier reaches saturation very quickly, and because it reaches saturation we get output distortion very easily. Positive feedback is ideally used to serve in oscillator circuits to convert DC signals into AC signals. When my feedback percentage is negative, what happens is that my input and the feedback signal are inverse of each other, 180 degree phase shift, and as a result they get subtracted from each other. This is called negative feedback. As a result, any faults that occur gets minimized due to the feedback. It improves the bandwidth of operation, and it also stabilizes the gain of the amplifier.